Welcome to Ask and Learn.
So they want us to come up with the covering relation for this partial ordering where AB and A is a subset of B on the power set of S, and S is just A, B, C. All right. Well, if you're unsure of what this definition is for a covering set, they explain it to us on page 66, or not 655, that they talk about this. And essentially what they say it is if we make the Haas diagram, the edges between those will be our covering set. So let's go ahead and start. So with the power set, well, we have just the set S itself. So up top, something that's going to be a subset of all of these, or contain every element, I should say, is A, B, C. So we have this up top here. Now, the next kind of sets we can have are sets of element size 2. So we could have AB here, and then we could have AC, and then we could have BC. So remember, I'm making the Haas diagram here, so we don't need to draw the self-relations or the directed for this because it's all implied going up. All right, so those would be the sets of element size 2. Now, what about the sets of element size 1? Well, that would be A, B, and C. And well, how do these relate? Well, A is a subset of AB, and A is a subset of AC. B is a subset of AB, and is a subset of BC. And then C is a subset of AC, and is a subset of BC. And then remember, we have a set of size 0 just being the empty set. And so this would be a subset of all those. So normally, remember, we would draw like the empty set going to here, to here, to here, and to there. And then likewise, A would also want to go to here, B would go to here, C would go to here, like that. But remember, since we're doing the Haas diagram, it's implied the transitivity properties hold. So we don't need to draw all those other lines. And doing it this way is not as messy either. All right, so we have this now. Well, all we care about is the ones that have these edges attached. So let's just go from the bottom and we can work our way to the top. So first we have, so phi and A, so, or empty set and A. So this is going to be one part of our covering set, or covering relation. So let's go ahead and erase that so we don't try to use it again. Now, the next one is going to be the empty set and B. So we can go ahead and get rid of this one. Then we have the empty set and C. So we can go ahead and get rid of this one. And now notice that phi isn't contained in anything else in this diagram, so we can just go ahead and get rid of phi now. All right. And so it's important that you write set A, set B, and set C as opposed to just A, B, and C, because A, B, and C have different meanings than the set A and the set B and the set C. So just kind of keep that in mind. All right, so now let's go and do A now. Well, so let's see. So we have A, and then this is with AB. So we can go ahead and erase this edge. The next edge we have with the set A goes to AC. So now we can go ahead and erase this edge. And we'll then notice A has no more edges, so we can erase that. Now, B, well, this has an edge to AB, and it has an edge to BC. So now we can go ahead and erase both of these here. And now B has no more edges, so we can go ahead and get rid of that. Now what about C? Well, C has the edge from A to C, And then it has the edge to BC. That should be curly brackets, not parentheses for this. So now we can go ahead and erase these two edges. And then C has some more edges, so we can go ahead and get rid of that. And now lastly, we would have the set AB going to ABC. So I'll write these over here. So it'd be AB and then ABC. So we can go ahead and erase this edge and then notice, oh, that there goes away. The next relation we're going to have is going to be AC to ABC. So now we can erase this edge and then look at that, that's gone. And then the last one we're going to have is BC to ABC. So BC to ABC. And so now we erase this edge, BC goes away, and then this has nothing that it is a subset of, so we can erase this too. So our covering relation is going to be this whole set right